So today I'm going to build an RF dummy load 50 ohm impedance. And this is, I'm doing this because I recently got my ham license and I have some transmitters to test. I'm not going to do all that much RF stuff on this channel, I don't think, but this is actually something that you could apply to any project, even if it's something like a DC power supply. I mean, you don't need the shielding for the dummy load, but it can be nice to have a load that you can dump 100 watts, and this is going to be spec for 100 watts or thereabouts of power into without it actually going up in flames. So how we're going to do this is rather simple. We're going to have a BNC like this. This is going to go into a large power resistor. This is going to ground. And then we're also going to have a fast diode like this. And this goes to a very small capacitor because, yeah, it's still RF. We don't need much capacitance. And this goes to another test point that's on the outside. And if you actually measure this in with respect to ground, you actually get the peak voltage of the RF over this resistor, or the voltage drop over this resistance, and that will tell you how much power is going into this resistor, which is great because then you can actually not only dump the power, but you can also do some measurement on it. Yeah, and I actually thought I might even add a second test point down here, so that you can actually, you don't have to clamp to the can that the thing is going to sit in. Because, yeah, this is RF, we need to put it in a shielded can, so it doesn't blast out a load of interference to everything while we're testing. And to build this actual can that the circuitry is going to be contained in, we're going to use, well, a can. Well, this is just a regular tin can, used to hold peas, I think. But we're going to use this, and we're going to then put all the circuitry in, and then solder it shut with a piece of circuit board, and this piece of circuit board is going to hold BNC into test points. And also it will hold some sort of valve. I don't know what to put in there. Maybe I'll just put a screw in. So that you can actually fill the inside up with oil, and that's going to help dissipate the heat that the 100 watts are going to pump in here. Yeah. And also it helps to isolate the resistors. I mean, they're rated for 500 volts each, but yeah, having a bit of insulation oil is probably going to help heat dissipation and a couple other things. For the actual resistors, we're going to use 20 of those 1K resistors. These are 2 watts each in parallel, and that gives us 50 ohms. If you're building a dummy load for some other impedance, you'd have to obviously use other resistors or different amount of resistors or whatever. Yeah, but I'm going to take basically 20 of these at this strip, and then I'm going to stick them in some proto board, and then I'm going to cover all of the other side with solder. Put some screw holes in there so that I can actually mount this hanging in here. And then we'll put all of this together and we'll have our dummy load. So this is the assembled resistor thing. It measures 49.7, which is alright enough. And I also cut out a piece of circuit board on which I will solder this. So next step in this would be to put a BNC in there, mount this on here, and then put the diode and the capacitor and the terminals in, and then we're already almost done. You just have to solder this closed. So next thing I did is just put a BNC connector on here, put two screws through here, 2 bolts, and then fasten this to basically on the side of this, so this is nice and grounded. And I also have drilled 2 holes into this, so I can actually sit this on here now. So, and then probably just connect this directly to there with a bit of lead. and then from here have a nice solid ground connection go up here, and then probably just solder a B and C directly to that connection. So this is basically star grounded and with the shield, and that should work reasonably well. And then we'll just have to put the additional jacks for the power measurement somewhere up here, and then we'll sort it all closed. So I have all of the stuff that goes on here sorted up now. I put this on those two standoffs, and then I connected this to ground down here, and I also have a diode connected from here to here, and a smallish capacitor that will just provide our reference DC voltage here. One problem that I'm just noticing that this now, I will probably put plastic screws in here, because this is actually very close to here, and this is a direct short to ground, so this is going to cause issues. So I'll replace that with nylon, and then it should be fine. So I've got my test setup here. I've got this multimeter directly connected to the contacts across the capacitor, and I've got my cheapy handheld plugged into here, like this, and I've got the can connected just by one sort of point back here, which isn't all that great, but for testing it might just work. So I'll just turn this on here, and yeah, that's 12 volts. So that is actually, let me just calculate this real quick. So that means I'm getting 2.88 watts out of this thing, and this is, I think, spec'd at 3 watts or 5 watts, but this is pretty close. This should be just about right. So we can actually see the power going in. Unfortunately, because this is rectified, we can't really see the actual RF signal. We have to use a sort of T-coupler and then go into the oscilloscope. But yeah, I'm pretty happy with this. I'm going to sort it up now. I'm going to fill it with oil, and then more RF adventures to come.